Let's solve this linear system by elimination. We have equation 1 and 2, which we'll label. And our goal here at first is just to get the same coefficients either on x or on y. In this situation, it's going to be easier to work with equation 2, in my opinion, because you only have to change the x coefficient. In this case, I'm going to multiply equation 2 by 3 so that I'll have the same x coefficient, both 3's. If I wanted to make the y's the same, I'd have to multiply both equation 1 by 3 and equation 2 by -2, so they'd both be 6, or -6, which would be a lot more work. I just need to multiply one equation here, in this case equation 2 by 3. So x times 3 is 3x, and 3y times 3 is 9y, and 3 times 31 is 93. I'll call that equation 2a to remind myself it's equation 2, but it's been slightly adjusted. Now the elimination step. I'm going to do equation 1 minus equation 2a. So equation 1 is 3x minus 2y equals -39, and equation 2a is 3x plus 9y equals 93. I put a minus with a circle. It's just a reminder to me to subtract everything, not just as minus 3x, which I'll do. 3x take away 3x is 0. But also -2y minus 9y is minus 11y. And -39 minus 93. Let's do that on a calculator to make sure we get it right. -39 minus 93. Oh, I hit divide. -39 minus 93 is -132. And how do I solve for y now? Just divide both sides by -11, and I get y equals 12. Well, I know y, which is great. I can sub y into one of the equations. So let's sub y equals 12 into, say, equation 1. Doesn't matter. Pick whichever one you find easier. This time I chose equation 1. Equation 1 is 3x minus 2y equals -39. So I'm going to replace the y value, -2 times y, except I know y now, it's 12. And now great, I have one equation, just with the x, I'm going to solve. I have 3x minus 2 times 12, that's 3x minus 24, equals -39. I'll add 24 to both sides, and I'll get 3x equals -19. And to solve for x, I just divide both sides by the coefficient of x, in this case 3, and I'm left with x equals -5. Therefore, the point of intersection is at -5 and 12. I can actually check my work if I'd like by subbing into both equations. So for equation 1, I'll check left side, right side. This will be my check. I'll check left side, right side by subbing in. So on the left side of equation 1, I'll put a 1 here, I have 3 times x, which is -5, minus 2 times 12. That's a little small there. I'm running out of room. So 3 times -5 is -15, minus 2 times 12 is -24. And then minus 15 minus 24 is -39, which, yep, checks out. So that's good. So let's try equation 2. Let's check it as well. There's some more room here. Left side, right side. So equation 2 is x, that's -5, plus 3 times y, which was +12. I could write down the right-hand side if I want right now. It's 31. So I get -5 plus 3 times 12, which is 36. -5 plus 36 is 31. Since both of the left sides equal both of their right sides, since this equals this and this equals this, I'm sure I'm right. And my check is done, and I'm super sure the point of intersection is -5, 12.